In this video, I'm going to be introducing the hyperbolic identities, which are very closely related to the trigonometric identities that we all know and love. Now, what I've got up here are the main three trig identities that we know of, and I've also written down the double angle formula as well. So what I'm going to do is I'm first of all going to show that we have an equivalent to this first one, then use that to derive the next two for hyperbolic, and then we're going to see if we can spot a rule that will allow us to go from trigonometric identities to hyperbolic ones fairly easily. Okay, so the good news is that you won't need to just memorize a whole load of new identities and double angle formulae when there is something called Osborne's rule that will allow us to convert between the two fairly easily. Okay? So, first things first is this. Back when I introduced hyperbolic functions, I introduced as to why they are referred to as hyperbolic functions, because they can parameterize the rectangular hyperbola x squared minus y squared equals 1, where we would be saying x is equal to cosh of some parameter t and y is equal to sine of some parameter t. So what I want to do is I want to prove that cosh squared take away sine squared is equal to 1. So that's what I'm going to go through here. So the left hand side, x squared minus y squared, well, I need to be able to write down these in terms of e to the t. So remember that cosh of t is e to the t plus e to the minus t over 2, and sine of t is e to the t take away e to the minus t over 2. So here we have e to the t plus e to the minus t over 2 all squared, take away e to the t, take away e to the minus t over 2 all squared. Now I'm going to expand these out, so let's expand out the numerators. So we've got e to the t times e to the t is e to the 2t. E to the t times e to the minus t is 1, and we're going to have that twice. And we're going to have e to the minus 2t as well, all over 4. Then take away e to the 2t, take away 2, plus e to the minus 2t over 4. Now I can factor out the quarter, and I would have e to the 2t plus 2 plus e to the minus 2t from there. Take away e to the 2t, take away minus 2, take away e to the minus 2t. So we can see that e to the 2t's cancel, e to the minus 2t's cancel, and I am left with 1/4 times 2 plus 2, and so we get 1. And that's the right-hand side. So clearly, we have cosh squared take away sine squared is equal to 1. And that is our first hyperbolic identity, and the one that marries up with this one here. So let's write that down. So we have cosh squared x take away sine squared x is equivalent to 1. Okay, that's our first hyperbolic identity. Now to get to the next identity, what we did over here was divide through by sine squared. Cosine squared divided by sine squared is cot squared. Sine squared divided by sine squared is 1. 1 divided by sine squared is cosec squared. So we're going to do the same job here by dividing through by sine squared. So cosh squared divided by sine squared would be coth squared x. Sine squared divided by sine squared would be 1. And 1 divided by sine squared would be cosec squared. Okay, so that's another identity. Now let's divide this one through instead by cosh squared. So cosh squared divided by cosh squared is 1. Sine squared divided by cosh squared would be tan squared. And 1 divided by cosh squared would be sec squared. Like so. Okay, so these are our 3 hyperbolic identities. Now, can we see the link between these and these? Well, obviously they look very similar, okay? They're in the same structure. The difference is that we've got a minus sign in front of the sine squared here. What I'm going to do with this one is I'm going to multiply the identity through by minus 1. That will make things easier for us to see, okay? So we've got a minus in front of the cot squared, we've got a minus in front of the cosec squared, and we've got a minus in front of the tan squared, or the than squared, rather. Okay, so what links sine squared, coth squared, cosec squared, and than squared? What links all of those 4 things together? Well, they all have sine squared involved, because we've got sine squared here, we've got cosh squared over sine squared there, we've got 1 over sine squared there, and we've got sine squared over cosh squared there. So they all have sine squared involved. So this is Osborne's rule. Okay, so Osborne's rule says that the hyperbolic identities are identical to the trig identities, but what you do is for every time sine squared appears, you put a minus in front of it, and then you turn them all into hyperbolics. So you put h's on the ends, okay? So, can we use that rule, can we use Osborne's rule, to now write down equivalent double angle hyperbolic identities? Okay, well let's try then. So, sine of 2x. Well, this doesn't involve sine squared, and so this doesn't change its format. So this is 2 sine x cosh x. So it is identical to this, apart from we put h's on everything. This one does involve a sine squared. So that means we need to change the minus to a plus. So we would have cosh of 2x is equivalent to cosh squared plus sine squared. Then, this one doesn't involve sine squared, so that's just going to still be 2 cosh squared x take away 1. This one does involve sine squared, so it's 1 plus 2 sine squared. Okay, and finally, tan of 2x. Well, tan x doesn't involve sine squared, but tan squared does, because it's sine squared over cosine squared. So we need to change this to a plus. So 2 tan x over 1 plus tan squared x. Okay, so this is Osborne's rule in practice. Okay, so essentially you don't need to memorize a whole load of new identities. As long as you know the trig ones, right, as long as you know those, you've got those in the bag if you remember Osborne's rule. Okay, and that makes your life a lot easier.